Hey folks, and welcome back to Pre-Calc. Today we're going to be covering radian measures of angles. You might have remembered this from Algebra 2. You might have horrible memories of radians. That's alright, we're going to work our way through them, and you're going to be a pro at it by the end of the class. Let's start off by defining what the heck a radian even is by using some common household objects. So first we're going to show what a radian actually is. I'm going to do so using a couple of circular objects. This is a candle. It lights up. Okay, the batteries are dead. But I'm going to measure its diameter. The diameter is about 3 inches. Then I'm going to use this flexible measuring tape, and I'm going to measure its circumference. So measuring the circumference of this, it's about 9 1/4. A little bit more than 9 1/4. So then let's take this. This is a trivet coastery thing that I have. I'm going to measure its diameter. Its diameter is about 7 1/8 inches. So I'm going to take this. I'm going to find the length of its circumference, and the length of its circumference is about 22 1/2. So with both of these so far, we've seen the diameter times about 3 is equal to the circumference. This is my son's drum. And I can see that its diameter, about 6 1/2. Its circumference, I'm measuring around the drum, it's going to be a little less than 21, but 6 1/2 times 3, about 21. Last but not least, another common household object. I have a bowl of chocolate cake that I just made. So it's about 5 1/2 for a diameter, and judging by what we've seen, this should be a little bit more than 5 1/2 times 3 is going to be 16 1/2, and it is. It's about 17 1/2. Now, how does that relate to radians? Let's check it out. So radians are a way of measuring the degree, gonna eat the chocolate cake, measure of a circle, but not using degrees. So we're just measuring how far we've gone around the circle using the relationship between the diameter or the radius of the circle and the circumference of the circle. So we know that the radius is half the diameter, and considering that, that's good cake, when we were talking about the circumference is about 3 times the diameter, so it's about 6 times our radius. And that allows us to find this thing called a radian. Let's take a look at what we can use radians for. So here we have a circle. We know the circumference formula of a circle is 2 pi r, and let's call this r, the radius. Well, if I do the circumference divided by the radius, I get 2 pi. Now notice, whatever unit my radius was measured in, if it was inches, if it was meters, if it was miles, that's canceled out. So this is our radian measure of a full circle, 2 pi. That doesn't have any units. So if I wanted to talk about radian measures, I would just say 2 pi radians. So we would say radians to indicate that we're doing it in radians, but if you don't see a unit next to a degree measure, we assume it's in radians. Now that's why I've been a stickler about putting the degree symbol next to angle measurements in degrees. If you see a degree symbol, it's in degrees. If you don't see any degree symbol, it's assumed to be in radians. So we can say this is 0 radians or 2 pi radians. We're going to go counterclockwise around the circle as we have before. Well, that means half the circle is just pi radians. I divided by 2. Which means if I do a quarter of the circle, I do 2 pi divided by 4. Well, that's pi over 2 radians for a quarter of the circle. And we can do similar things to find what we would normally call 30 degrees, 45 degrees, and 60 degrees. For instance, if I wanted to say 45 degrees would be about there, 30 degrees would be about here, and 60 degrees would be about here. Well, this is going to be 30 degrees, so that's going to be 2 pi divided by 12. The reason 12 is that 30 goes into 360 12 times. Well, that's pi over 6. Now this, representing 45 degrees, well, that's going to be 2 pi divided by 8. That's because 45 goes into 360 8 times. Well, that's going to be pi over 4. Over here, this would be 60 degrees, that 2 pi over 6, because 60 goes into 366 times. That's going to be pi over 3. So these three measures are very common when we're talking about radians. Pi over 6 is your 30 degrees, pi over 4 is your 45 degrees, and pi over 3 is going to be your 60 degrees. Then you have pi over 2 when we're talking about 90, pi when we're talking about 180, and either 0 or 2 pi when we're talking about a full circle. So let's show how we're going to convert these two degree measurements to radians. We're going to use the fact that pi radians is 180 degrees. So I want to cancel out the degree. I'm going to multiply this by a fraction using pi and 180 degrees. Since the degree has to cancel out, the 180 degrees has to go in the denominator. Pi has to go in the numerator. Well, then I just simplify this. 60 goes into 180 3 times. 60 goes into itself once. So my answer here is 1 pi over 3, or just pi over 3. Similarly, if I wanted to do this with 120 degrees, I would do pi over 180 degrees. Notice the degrees are on opposite sides of the fraction, so they're going to cancel out, which is what we want. 60 goes into that twice, 60 goes into that 3 times, so I'm left with 2 pi over 3. Now, suppose I wanted to convert to degrees. Now, if I wanted to go ahead and do that, I'm still going to use my pi radians is equal to 180 degrees. What I'm just going to do is multiply by something else. So if I wanted to do both of these, I want a degree in my final answer in my numerator. So I'm going to multiply by 180 degrees over pi to both of these. Now, what you're always going to see when you're converting to degrees is pi is going to cancel out. We would expect that. You normally don't have pi degrees. Well, then I can just do 180 divided by 4. And that's going to give me 45. Then 3 times 45 is just going to give me 135 degrees. Similarly over here, the pi's are going to cancel because they're in both parts of the numerator. And then I can just do 180 divided by 8. That's going to give me, I can do 180 divided by 4. That's going to be a bit easier. So 180 divided by 4 is going to be 45. 8 divided by 4 is going to be 4. And then I can just multiply 7/4 times 45. And that's going to end up giving me that's going to give me 157.5 degrees. So typically, radian measures are always going to have a pi. We leave them as fractions. Please do not convert these to decimals. This is the exact way of writing it. You try to convert this one to a decimal, because pi is irrational, this decimal is going to be inexact. You'll have to round at some point. Because these are degrees and the pi's are going to cancel out, we typically are going to write them as a whole number. They can be a decimal, it can be an easy decimal, but typically the degrees are going to be whole numbers or easy decimals. So we're going to use radians and find the exact value of trig functions. We're going to write our answers in simplest form with rational denominators, as you've done in the past. So here we have for our first one secant of pi over 4. The first thing I'm going to do is convert pi over 4 to degrees, something that we can see a bit better. So pi over 4 times 180 over pi. Well, the pi's are going to cancel out, and I'm just going to be left with 180 divided by 4 is going to be 45 degrees. Well, here, a little diagram is going to help. We're just in the first quadrant, so I'm just going to draw the first section of my unit circle. And I know that's my terminal ray. This is at 45 degrees. This is a 90. Well, I know from special right triangles that this is going to be radical 2. That's going to be radical 2. That's going to be, that's going to be 1. That's going to be 1. That's going to be radical 2. That's my relationship here. So secant is 1 over cosine. Well, cosine of 45 degrees is going to be equal to, using SOHCAHTOA, 1 over radical 2. Well, that means that secant of 45 degrees is equal to radical 2 over 1, so just radical 2. So let's do a second one. We have cotangent of 2 pi over 3. Same thing as before, my first step is going to be to translate that into degrees so I have a better idea about what's going on. Well, 2 pi over 3 times 180 over pi. 3 goes into 180 60 times. The pi's cancel out, so I'm left with 2 times 60. That's 120 degrees. So we're going to draw a little diagram out now. 120 degrees is in the second quadrant, so I'm just going to draw, you can just draw a half circle if you'd like. That means this is going to be my 120 degrees. Well, I'm in the second quadrant, so that means my reference angle is going to be 60. So using special right triangles, if that's 60, that's 90, and that's 30, well, 30, side opposite 30 is 1, the hypotenuse is 2, and the other side is radical 3. That's just special right triangles. I'm in quadrant 2, so that means this has to be, this has to be negative, because my x values are negative. Well, I know that tangent of 60 degrees, I can find that by SOHCAHTOA. That's going to be the opposite, radical 3, over my adjacent, negative 1. That means cotangent of 60 degrees is just the opposite. It's going to be negative 1 over radical 3. Well, I would need to rationalize this now. So radical 3, radical 3. Denominators multiply out to just be 3. My numerator stays negative radical 3. And this will be my final answer. Great. So you've seen how to convert between degrees and radians and back again. You've seen how to evaluate the 6 trig functions that we've covered using radians and the unit circle. Now you're going to go on to Delta Math and you're going to give it a shot. All right, these are all on Delta Math, so you don't have Q questions, you don't have any of those questions. All you got to do is Delta Math. After that, you're just going to do the summary in a Google form, so no Flipgrid either. And then you're just going to do the reading check for the next section. Remember, you can do that reading check as many times as you want to get full credit. So, thank you for bearing with me, and I think you'll find this lesson is a piece of cake. It's still a good cake.